The other metals are the metallic elements located between the transition metals and the metalloids on the periodic table. Compared with the transition metals, the other metals are generally softer, have lower boiling and melting points, and are more electropositive. Aluminum is a silver-white metal that makes up 8% of the Earth's crust. Although it is the most abundant metal on the planet, it is never found in its pure form. Instead, it must be separated from other minerals by a complicated electrolysis process. Aluminum is used in millions of products across the globe, and it is the most commercially important of the other metals. It is the main metal in electrical transmission wires. Gallium is a blue-gray metal that is used to produce semiconductors, transistors, quartz thermometers, and low-melting alloys. A compound of the element gallium arsenide can produce laser light directly from electricity. Indium goes into solar and photo cells, transistors, mirrors, nuclear power regulators, and as a coating for high-speed bearings. Tin is a silver-white metal that can be found in nature in its metallic state. Tin has good resistance to corrosion. Tin plating, placing a thin layer of protective tin coating over other metals, is the primary use of the element today. Tin becomes brittle at very low temperatures, and some believe that this property may have contributed to Napoleon's defeat during the freezing Russian winter. Thallium is a poisonous soft silver-gray metal that has no uses in its pure form because it readily combines with oxygen and water vapor to form a black powdery substance. Thallium compounds are used to create low-melting glass and alloys and to make infrared radiation detectors. Lead is a soft silver-blue corrosion-resistant metal that darkens rapidly when exposed to air. Today, lead is used in many products, including storage batteries, solder, metal alloys, and radiation shielding. Lead has been known since ancient times. The Romans used lead to line their aqueducts and make water pipes. But prolonged exposure to this element can be deadly, which may have contributed to the fall of Rome's great empire. Bismuth is a white brittle metal with a slight pink tint. It resists becoming magnetized more than any other metal. It also is the least heat-conducting metal after mercury. Bismuth is used to manufacture metal alloys, acrylic fibers, plastics, electrical fuses, and automatic fire sprinkler systems. All other metals are opaque metallic elements that have relatively high densities. These elements are generally ductile and bendable, like the transition metals, and they also exhibit some very different properties. Compared to the transition metals, the other metals are generally softer and have lower boiling and melting points. Their atoms are more electropositive, meaning that they lose valence electrons more easily than the transition metals. These differences can be explained by taking a closer look at where the other metals reside on the periodic table. On the periodic table, the elements are listed in order of their atomic number. The atomic number represents the number of protons in an element's nucleus. In its normal or ground state, this nucleus is also surrounded by an equal number of electrons. And as the atomic number increases, generally so does the size and mass of the atoms. As you read the periodic table from top to bottom, each horizontal line is called a period. Each period represents the number of electron shells the element's atoms normally have. For example, there are 4 electron shells in an atom of gallium, so it lies in period 4. Meanwhile, an atom of thallium in period 6 has 6 electron shells. As you read across the table from left to right, the vertical lines of elements are called groups. Elements in one group have the same number of electrons in their outermost electron shells. These are called valence electrons, and they dictate how elements interact.